Good morning, dear friends. Welcome to my channel, Guru. My name is Mahesh Kumar, Senior IT Maths Lecturer. In yesterday's class, we have discussed about rule number 4, and today we are going to see rule number 5 of partial fractions. Let us see what is rule number 5. Right? So till now, whatever we have discussed, those are belongs to 1, 2, 3, 4. Those are proper fractions. And today, especially, we are going to learn the partial fractions of improper fractions. In the beginning, the day 1 class, we have discussed what is proper and what is improper fraction. Now, we are going to deal problems on improper fractions. Already we have seen improper fractions is of two types. When degree is equal and when degree is more. When numerator degree is more, we call it as improper function. So here we are getting two different cases. First, let us go for the first case. What is case 1 says? In case if degree of g of x is same as degree of f of x, right? In case if degree of g of x and degree of f of x both are same, then what to do? Just by using the division algorithm. By using division algorithm, what you can write? The division algorithm says dividend equals to divisor into quotient plus remainder. So using that, here we are going to write the fraction f of x by g of x. In case f of x by g of x is improper fraction and degree of f of x is same as degree of g of x, in such case we are using the division algorithm and f of x can be written as k into g of x plus r of x. So this is what division algorithm, right? So there exists a constant k. There exists a constant k as well as a polynomial g of x such that f of x can be written as k into g of x plus r of x. And here this r of x may be equal to 0 or that might be a polynomial with a lesser degree compared to f of x, right? So this is about f of x, but we need f of x by g of x. If we divide everything with g of x, what we get? F of x by g of x is k plus g of x gets cancels r of x by g of x. So the given fraction converts in the form of k plus r of x by g of x. And what is k? K is quotient. Which quotient? Quotient of coefficients of f of x and g of x. So quotient nothing but division. Division of the coefficients of f of x and g of x. And what about this r of x by g of x? R of x by g of x convert into proper fraction, right? So again, how to solve proper fraction? Already we have discussed 4 different rules. So using rule number 1, 2, 3, 4, any one of using these rules, we can find its partial fractions. So this is about case 1. What is case 1? In case degree of g of x and degree of f of x are equal. In such case, by using division algorithm, what we are getting? We are getting f of x is something divisor into quotient plus remainder. So divisor into quotient plus remainder. What is quotient here? Something k we get, constant, because values are equal, degrees are equal. Then by dividing with g of x, we are going to get f of x by g of x is equals to k plus r of x by g of x. So this f of x by g of x can be written as k plus r of x by g of x. And what is k here? K is a constant. Which constant? A constant which is obtained by taking quotient of coefficients of f of x and g of x. Nothing but division of highest terms of f of x and g of x. And what is r of x by g of x? R of x by g of x converts into a proper fraction, and this can be done using any one of the rule 1, 2, 3, 4. And coming to second case, what is case 2? Case 2 is in case degree of f of x is greater than degree of g of x. In case numerator degree is more than the denominator, then what we get? Again, by using division algorithm, we can write f of x as something q of x into g of x plus r of x, right? So here what we get? We get quotient as something q of x into divisor plus remainder r of x. Again, r of x might be 0, r which is less than to the degree of g of x. And again, what we need? We need fractions of f of x by g of x. So let us go for f of x by g of x. What we can write? This can be written as q of x plus r of x by g of x. And what is g of x here? Q of x. Q of x is a polynomial coefficient. Plus what is rx by gx? Once again, this rx by gx converts into proper fraction. So again, this can be solved by using any one of the rules which we have used earlier. By using 1, 2, 3, 4 rules, we can find partial fractions of this. And what is q of x stand? Q of x is a quotient polynomial coefficient, right? So this is about rule number 5. What rule number 5 is? Improper fractions of f of x by g of x. In this we have two different cases. One is when degrees are equal, other one is when numerator degree is more than the denominator. In the first case, we get of the form f of x by gx is same as k plus r of x by g of x. And what is k? K is the quotient of coefficients of f of x and g of x. And what is this r of x by g of x? Which is a proper fraction which can be solved using any one of the rule 1, 2, 3, 4. And in case 2, this can be written as f of x by g of x is q of x plus r of x by g of x. Again, q of x is nothing but polynomial quotient of polynomial, and this can be done again using any one of the rule 1, 2, 3, 4. Now let us see these two using some examples. I am going to give examples for this case 1 and case 2. Right. The question is, resolve x power 4 by x minus 1 into x minus 2 into partial fractions. So this is a question, right? It's asking to find partial fractions of this. First, let us verify whether the given question is proper or improper. So given x power 4 by x minus 1 into x minus 2 is a, so what is degree of numerator? 4. Degree of denominator? 1 plus 1, 2. So numerator is more than the denominator, is a improper fraction. When the question is improper, so we need to discuss two cases, whether degrees are equal or the numerator degree is more than the denominator. Here clearly you can see that degree of f of x is greater than degree of g of x. So because degree of f of x is greater than degree of g of x, what we get? We get the quotient as a polynomial. So that we need to divide the given question with the g of x. Let us take that first. What is given? X power 4 by x minus 1 into x minus 2, which is x power 4 by, let us multiply this, x into x, x squared, x into 2, minus 2x, minus 1 into x, minus 1 into minus 2, plus 2, which is x power 4 by x square minus 3x plus 2. So the given question is x power 4 by x square minus 3x plus 2. Because degree of numerator is greater than degree of g of x, we need to divide this to get the quotient. So let us divide. So if you go for division, we need to divide x power 4 with what? X square minus 3x plus 2. Right? So what we can write here? When how many times x power 4 comes in x square table? X square times. Right? So x square into x square gives x power 4. X square into 3x gives 3x cube. X square into 2 gives 2x square. Let us change the signs of this. So this is minus, this turned into plus, this turns into minus. Here you can see here x power 4 gets cancelled, remaining 3x cube minus 2x square. Once again, how many times 3x cube comes under x square table? 3x times, right? So 3x into x square, 3x cube, 3x into 3x, 9x square, 3x into 2, 6x, right? Again, let us change the signs of that. So this comes to minus, this goes to plus, this goes to minus. Now 3x cube minus 3x cube gets cancelled. 9x square minus 2x square is 7x square minus 6x. Once again, so this 7x square comes under 7x square table 7 times. So 7. So what you can write here? So 7 into x square, that is 7x square. 7 into 3x, 21x. 7 2s are 14. Let us change the signs once again. If we change the signs, this goes to minus, this comes as plus, this is minus, right? So 7x square gets cancelled. 21 minus 6 is 15x minus 14. Here the divisor quotient is 2, and whereas this is a linear factor, so which cannot be divisible. Hence we can write by using division algorithm. What we can write using division algorithm? The given question, which is x power 4 by x minus 1 into x minus 2. What we said? Quotient. What is quotient here? X square plus 3x plus 7 plus r of x by g of x. What is r? Remainder. Remainder is 15x minus 14 by divisor g of x. What is divisor? X minus 1 into x minus 2. So this is what required answer, right? But now what happens? Once again, this converts into partial fraction because this is a proper fraction. So because it is a proper fraction, once again we need to divide them. So go for the division. Let us consider that. Consider 15x minus 14 by x minus 1 into x minus 2. You can observe here, numerator degree is 1, denominator degree is 2. So this is a proper fraction. So to get the partial fractions, here these are the linear factors. So because these are the linear factors, use rule number 1. What is rule number 1 says? A by x minus 1 plus b by x minus 2, right? Now let us find those values. So to get the values, 15x minus 14 can be written as a into x minus 2 plus b into x minus 1. Here we need to find the values of a and b. To get the values of a and b, let us put x equal to 1. So what happens? 15 into 1 minus 14 is equals to a into 1 minus 2 plus b into 1 minus 1. 15 minus 14 is 1. A into 1 minus 2 is minus a. This gets cancelled, which implies a can be written as minus 1. We got a value. Next, to get b value, put x equals to 2. So what we get here? 15 into 2 minus 14 is equals to a into 2 minus 2 plus b into 2 minus 1. This gets cancelled. 15 2s are 30, minus 14 is 16. 2 minus 1 is 1. 1 into b is b. B value 16. So this is value of b. We got both a and b. Hence from 1 and 2 we can conclude the answer. So what we can conclude from 1 as well as 2, the given question x power 4 by x minus 1 into x minus 2 is x square plus 3x plus 7, and this is converted into a by x minus 1 plus b by x minus 2. What is a? A is minus 1. So minus 1 by x minus 1. B is 16. So 16 by x minus 2. So this is what the required partial fraction. I think it is clear for you, right? So what is given question? X power 4 by x minus 1 into x minus 2. We need to resolve into partial fraction. So because numerator degree is more than the denominator, we have divided the given question. Then using division algorithm, we have taken this. Then this goes as proper fraction. We have considered this again by using rule number 1. We have solved it as a by x minus 1, b by x minus 2. By simplifying, we got a, b values. Hence by 1 and 2, we got the final answer. This is greater than case. Let us take one more example with equal case, right? So let us take one example with equal case so that you can easily understood the difference between the numerator greater than case and equal case. Right. So the question is resolve x cube by 2x minus 1 into x plus 2 into x minus 3 into partial fractions. The question is x cube by 2x minus 1 into x plus 2 into x minus 3. We need to solve into partial fraction. Let us go for the simplification. First, the given, what is given? X cube by 2x minus 1 into x plus 2 into x minus 3 is a. Always we need to verify whether the question is proper or improper. You can observe here, degree is 3, 1, 1, 1. So degree goes 3. Both are equal. If equal powers are greater than case, we solve it as improper. So this is a improper fraction, right? So we got improper fraction. But again in improper fraction, we have two kinds. One is equal case, one is greater than case. Clearly you can see here equal case. So degree of f of x is equal to degree of g of x. We got equal. In equal case, it is very simple to write. Let us take the given question x cube by 2x minus 1 into x plus 2 into x minus 3 is, already we have discussed, we can write it as k plus r of x by g of x. What is k? K is a quotient, nothing but division of the coefficients, highest coefficients f of x as well as g of x. What is x cube coefficient? 1 by what is x cube coefficient? You can see here 2x into x, 2x square. 2x square into x, 2x cube. So what is x cube quotient? 2. Nothing but 1 by 2. So when equal case, we get the value k. How we get k value? By taking quotient of coefficients of f of x and g of x. X cube quotient is 1. Denominator x cube quotient is 2. Plus the remaining goes r of x by g of x. Nothing but for this we need to write partial fractions. Again here each and everything is a linear factor. So because these are the linear factors, again use rule number 1. What is rule number 1? A by first factor 2x minus 1 plus b by x plus 2 plus c by x minus 3. So this is what the required answer, right? Here we need to find ABC values. To get ABC values, let us take the LCM first. If we go for the LCM, what happens? X cube by 2x minus 1 into x plus 2 into x minus 3 by, what is LCM for this? 2 into 2x minus 1 into x plus 2 into x minus 3. 2 is present, other than 2, remaining 2x minus 1, x plus 2, x minus 3. 2x minus 1 is there, other than that 2, this and this, that is 2a x plus 2 x minus 3 plus, other than x plus 2 remaining 2b 2x minus 1 x minus 3 plus, other than x minus 3 remaining 2c 2x minus 1 into x plus 2. So denominator gets cancels. So still in the denominator we have 2. So take the cross multiplication. So what we can write now? We can write it as 2x cube is equals to 2x minus 1 into x plus 2 into x minus 3 plus 2a into x plus 2 x minus 3 plus 2b into 2x minus 1 x minus 3 plus 2c into 2x minus 1 x plus 2. Now this is what you can take it as equation number 2. But what we need ABC values. Already we have 3 factors. So by replacing method we will get all the 3 values. Let us go further. First factor is 2x minus 1. So that x becomes 1 by 2. So let us put x value as 1 by 2. So what happens? 2 into 1 by 2 whole cube, which is equals to, here 2 into 1 by 2. 2x minus 1 we are taking as 0. So the entire term becomes 0 plus 2a into x plus 2 is 1 by 2 plus 2 and 1 by 2 minus 3. Again here 2x minus 1 is present. So because 2x minus 1 present, so wherever 2x minus 1 is there, we can take those values as 0 just because we have replaced 2x minus 1 as 0. So this becomes 0 and the next value becomes 0. So 1 by 2 whole cube is 1 by 8 and here 2a into 1 by 2 plus 2 is 5 by 2. 1 by 2 into minus 3 is minus 5 by 2. Here 2 ones are 2 fours are gets cancelled, right? So 2 twos are 4, 4 gets cancelled. What is remaining? 1 is equals to 2 fives are 10, 10 fives are 50. So minus 50a, a nothing but minus 1 by 50. We got a value. Then go for the second one. What is second one? Second one is x plus 2. X plus 2 equal to 0 means x value minus 2. So just let us replace x value minus 2. Again, because of x plus 2, wherever x plus 2 is present, that values becomes zeros. Just we need to replace in the other. What are other values? 2 into minus 2 cube. So this is 0 and this is 0 plus 2b into 2 into minus 2 minus 1 minus 2 minus 3 and this is 0. So 2 into minus 2 cube is minus 8, which is this is 2b into 2 to the 4 minus 4 minus 1 is minus 5 minus 2 minus 3 is minus 5. So 2 gets cancelled and minus 8 equals to 5 5s are 25, minus into minus plus 25b. So b is nothing but minus 8 by 25. Even we got b value. Next what we need to find? C value. To get what is the other factor? Other factor is x minus 3. So when x minus 3 equal to 0, what is x? x equal to 3. So let us put x value 3. So put x equal to 3. So when we replace x equal to 3, what happens? 2 into 3 cube is equals to, once again you can see here already x minus 3 is present, x minus 3 is present, x minus 3 present. So these three terms becomes zeros. So 0 plus 0 plus 0 plus 2c into 2x minus 1, which is 2 into 3 minus 1 and 3 plus 2. So 2 into, what is 3 cube? 27 is equals to 2c. This is 5 and this is 5. So 2 gets cancelled. 27 equals to 5 is a 25c. Hence c can be written as 27 by 25. We got a value, b value, c value. Once after getting all the values, just replace the values in first equation. Hence from equation number 1, what we can write? The given question, x cube by 2x minus 1 into x plus 2 into x minus 3 is 1 by 2 plus a. What is a value? Minus 1 by 50. So minus 1 by 50 into 2x minus 1 plus b. What is b value? Minus 8 by 25. So minus 8 by 25 into x plus 2 plus c values 27 by 25. 27 by 25 into x minus 3. So these are the partial fractions of the given question. I think these are clear to you. We have done today improper fractions. In improper fractions, we have two kinds. One is first case, which is degrees equal, and the other case when numerator of f of x, degree of f of x is greater than degree of g of x. What to do, we have learned today. I think these are clear. In the next class, we are going to solve few more problems. Thank you very much.